In this video, we're going to go through an example to determine whether or not a particular system is linear. And for this video, the example we'll use is a system where you have an input and you have an output, y of t, and the output is just equal to the input squared. Oops. I got so excited when I said squared, I was going to draw a square around it. Okay, so this is sometimes called a squarer for obvious reasons. And the question we would like to ask now is this system linear? In order to determine if it's linear, we have to determine if it is homogeneous and if it is additive. So we'll start with homogeneity. The idea, if you'll recall from the definition, is to determine if a system is homogeneous. It will be homogeneous if ax of t goes into the system and a y of t comes out. So the question is that we have to ask is, when I put ax of t into this system, does ay of t come out? Well, let's actually do that. So we put ax of t into this system. The thing that comes out is going to be ax of t squared, okay? Because this is a squarer. And I can write this as a squared x squared of t. Now, y of t, the output of the system when x is the input, is x squared. So this much is y of t. But you'll notice that instead of having an ay, which is what I need in order for it to be homogeneous, out here I have a squared. So this system is actually not homogeneous, because again, if I put ax of t in, I don't get ay of t out, I get a squared y of t out. Okay, so we can say then that this system is not homogeneous. Okay. Now, if we're trying to determine if the system is linear, and that's our only objective, we could stop right now, because if it's not homogeneous, it can't be linear. But because, of course, we're interested in learning more than we are in knowing if this particular system is linear or not, let's check to see if the system's additive, because, of course, that will be instructive. Okay, so first we'll tidy up a bit. Okay, so for a system to be additive, again, if I put x1 of t in, then I'm going to get some output y1 of t, which, because the system squares the input, is just going to be x1 of t squared. If I put x2 of t in, I'm going to get another output y2 of t, which is going to be x2 of t squared. Okay, so now the question I have to ask is, if I put x1 of t plus x2 of t, is this going to give me y1 of t plus y2 of t? Okay, so that's the burning question, is if the sum of the two guys going in gives me y1 of t plus y2 of t. So let's just see what happens. If I take this and put it into the system, the output of the system is going to be x1 of t plus x2 of t, that whole quantity squared. And if I work this out, this is essentially squaring a term with two terms. So you'll, of course, remember that this is x1 of t squared plus 2x1 of t times x2 of t plus x2 of t squared. Okay, so now we can start comparing what we have coming out of the system in response to this guy going in. This term, x1 of t, looks exactly like what happens if I just put x1, or I'm sorry, the term x1 squared of t looks exactly like the term that I get when I put x1 of t in. Okay, so this guy here, I can now say is y1 of t. Similarly, x2 of t squared is exactly what I get when I put x2 into the system. So this is y2 of t. But you'll notice, and this is the part that we're actually trying to figure out, this term here, the product, 2 times the product of x1 and x2, this term does not show up either as y1 or y2. So the output of the system when I put x1 plus x2 in is going to be y1 plus y2 plus this term. Okay. So it turns out the answer to this question, if I put x1 and x2 in, do I get y1 plus y2 out? The answer to that is no. And so we can say then that this system is also not additive. Okay. So this system is neither homogeneous nor additive, and that means that it is not a linear system.